Welcome to the Burst and Static Pressure Testing System project, sponsored by Dixon Quick Coupling. I'm Daniel Spencer, and I'll be guiding you through the project. So when Dixon brought us on for this project, we immediately identified some key opportunities with the old machine. Even though it was rated for the desired 50,000 psi, it didn't reach it. It couldn't produce pressures below 2,000 psi. The adapter mount would be damaged during burst tests of large parts, meaning the machine would have to be removed from service for repairs, and it didn't retain the raw data for export. So the key measures we took to resolve these issues are a reinforced frame that reinforces the adapter mount, a modular design to simplify repairs and upgrades in the future, a two-pump system that allows accurately producing low and high pressure, and the LabVIEW software is programmed for complete data retention. The new design's frame is primarily constructed of 1.5" square 6061 T6 aluminum tubing with aluminum sheeting around the hydraulics. There are 2 layers of polycarbonate shielding around the test chamber, and the test chamber is capped with a 1/4" plate of 6061 T6 aluminum. And finally, the whole frame is mounted on a set of lockable caster wheels to keep the whole assembly mobile. For our hydraulic system, we've gone with a 2-pump design, pairing a 4,500 psi low pressure pump with a 70,000 psi high pressure pump. This lets us accurately produce pressures from 100 to 60,000 psi for static pressure tests, and gives us a small amount of insurance at the top end in case of problems with the pressurized air supply, as this is a pneumatically powered system controlled by a set of solenoids. This diagram shows the remaining features of the hydraulic system. Most importantly, the check valve that protects the low pressure pump from the high pressure pump, and the air-operated normally open valve that automatically depressurizes the system in the event of a pressure loss, as well as depressurizing it at the end of static pressure tests. On the electronic side, the system uses a magnetic switch to make sure the door is closed before it begins pressurizing. Once the high pressure transducer that records the pressure data for the tests reports that the system has begun pressurizing, the system engages the electronic latch and does not disengage it until the transducer reports that the system has fully depressurized.